undisturbed. Okay. So let's begin. So good afternoon, fellow Foundrymen and distinguished members of the Institute of Indian Foundrymen. It gives me immense pleasure in welcoming you all to yet another enriching technical webinar organized by the Institute of Indian Foundrymen Chennai chapter. Today marks the 10th webinar of this tenure and 57th program conducted under the chairmanship of Mr. P. Senthil Kumar. Though our chairman could not be with us here today due to travel commitments returning from another program conducted today at IIT Tirupati by the IIF Chennai chapter, it is indeed an honor for me as the immediate past chairman to welcome you all on his behalf. This afternoon session, sorry. Sir, please. This afternoon session is on a very relevant and practical topic, optimizing foundry casting finishing with trimming machines, functions and advantages. The webinar will be delivered by Mr. M. Mathivanan, General Manager, Mahalakshmi Tools and Machinery Private Limited, an expert with extensive experience in foundry automation and finishing solutions. In today's competitive foundry environment, the focus on productivity, consistency, and safety has never been greater. Casting finishing operations, especially trimming, plays a very crucial role in ensuring dimensional accuracy, surface quality, and reducing manual dependence. So, as foundries move forward towards automation and lean manufacturing, understanding the advantage of trimming machines becomes very vital for improving overall process efficiency and product quality. We are fortunate to have with us Mr. Mathivanan, who will share his valuable insights and experiences on the subject. On behalf of the Institute of Indian Foundrymen Chennai chapter, I extend a very warm welcome to you, sir, and thank you for being with us today. I also welcome all our participants and request each one of you to give your full attention and make the most of this session. May I now request Mr. Joe Buvraj, our council member, IIF Chennai chapter, to introduce the speaker for the day, please.
Thank you, Vignesh. Yeah, it's my privilege and warm welcome for today's afternoon webinar. It's the great honor to pleasure introduce the esteemed guest speaker for today's IIF webinar, Mr. Mathivanan Mahalingam, and he has got vast experience, and he's basically a mechanical engineer and an MBA. And I just want to brief and tell you the notable accomplishment done across his career. He visited many places, Russia, China, Singapore, and contributed Indian Navy submarine engine assembly fuel loading cell projects, Turkey projects, wind energy, tower fabrication, GRA India, and redesigned internal auto welding machine. And to brief on his career, I would like to tell that he started his career on July 2000, Sharpline Automation Private Limited, Sharpline CNC Technology Private Limited, Chennai as a project engineer. And from there, he moved on to Tejas Machinery Private Limited, Chennai as a project manager. From there, he's been working as head design development welding automation at ESAB India. And from June 2019 to June 2021, he worked in Matrix Motion Control Private Limited, Pune as a senior manager design engineer project. And now he's finally working in Mahalakshmi Tools. And to add on, Mr. D. Sundar also will be there in today's session in the question and answer session. And the webinar is yours, sir. Madhi, sir.
Yeah, Mr. Yuvraj, thanks for introducing me, and thanks, Mr. Vignesh, for that conducting this wonderful seminar. Yeah, let me talk about that metal
Sir,
finishing
you can
process.
share your screen, sir.
Just a minute. Audio is okay, sir? Am I
Yeah,
audible
audio
now?
is perfect. Audio is perfect.
Okay. Okay, is it okay
Yeah.
now?
Yeah.
Yeah. Today, I'm going to discuss about that trimming process in casting finishing process. This is one of the casting finishing process. Nowadays, it's a very modern process. I will introduce ourselves in that slide. The MTM was started on 1985 as a tool room manufacturer. Mr. Sundar started this company 35 years ago. Then we slowly recognized by the industry, and 1990 we opened a full-fledged design office in 2000, jigs and fixture, mold, die manufacturing facility, and 2006 precision SPM. Now we are making all the sectors SPMs and casting industry trimming machines. This is about our journey of MTM. Who we are. If you go through that slides, who we are, especially we are concentrating manufacture of hydraulic machines, high precise metal component, and SPM builder for various industry. I'll put up some classic examples as below. In construction industry, automobile industry, battery and junction fixture, heavy fabrication industry, and casting industry. Yeah. Is it visible now, sir?
Yeah, it's visible, sir. Very much visible.
Yes. Yeah. For the casting, for the construction industry example, I just put one slide. We can able to see this construction machinery equipment, like that very big multi-story building construction nowadays require that from ground floor to that top level stories, we need to pour the concrete. So for that, we require the machineries. We are making the machineries for making these booms. So this is for the construction machinery parts we are also making. So next one is that we are in that automobile and tire industry. We are making door hinge automation machineries as well as tire manufacturing machines parts also we are making. This is for automobile and tire industry. And we are in battery industry also, and junction fixtures also. We are making that heavy earth moving equipment machineries also. This is for that machineries we are making to do that positioner, such a kind of welding. We are also contributing a lot. And now that new emerging field, that insulation material making machinery. This is a railway insulation material machinery. So we are making these machineries nowadays. We are also in heavy fabrication machineries. If you would have seen this, how big this is, if you refer this photo. Correct, no, sir? Then this is also is one of the field. Now we are coming to the casting industry. This is actual our webinar today. We are making metal casting finishing machineries like a trimming for automobile brake drum, brake housing, carrier industry for car, as well as that in engine component, as well as that piping industry, as well as that cranking rocker arm component, some pump industry. This is for that example to understand. Just I'm projecting those things. So casting finishing process transformation in India. So this is the heading. Why we need to concentrate on the trimming machines in modern machinery. Indian industry considerably growing every year compared to other country. Our average growth rate is now recent years is around 6, from 5 to 9. In extreme cases, we reached up to 9, and the average growth is around 6. So every region in India growing educationally, economically, and work culture wise. Why I am putting this point here? 10 years back, we can able to get enormous manpower. That poverty rate and education rate, these are very lesser. So you can able to get the manpower whatever you required and wherever you required, but not nowadays. So this is the point why I am putting here. The third one is due to the faster individual personal economic growth rate, the workforce availability for the particular hard work, casting, finishing are getting declined year on year. That means I assuming or we are expecting another 5 to 10 years, almost 30 to 40% of manpower will expel from this industry to doing this pit metal finishing operation in casting industry. So the transformation from manual finishing to trimming is essential for the Indian foundry industry to improve our quality, safety, productivity, and global competitiveness while addressing labor challenges and modern manufacturing demand. So this is one of the major point why we require this trimming machineries. That another point is the transformation of casting finishing process are adapting day by day. So now today is trimming with a manual or hydraulic process. Tomorrow with a CNC trimming. Day after tomorrow maybe the AI adapted CNC trimming. It might be there, but nowadays we are using with the hydraulic trimming for the particular finishing process. Also, the people started designing their component, considering easy to do finishing process, easy to do the finishing process. That old design scenario, people do with what they are required for the functionality. But nowadays, how to do that also they are considering more compared to the earlier days. So this is a major transformation happening in India in the finishing process. Yeah, I'm just sharing that bottleneck of traditional casting finishing process and fettling. If you see the photographs, you will understand that what are all there in that. You require excessive workforce, 100% dependency on the workman to finish the casting. Fatigue and health hazard will always happen. It's a dusty atmosphere. Quality issue over grinding, dimensional inconsistency and mismatch always will happen. To overcome this, we are introducing the uh, trimming process. That means the hydraulic trimming process, MTM trimming machines. So if you see the photographs, this is the environment we required for fettling or other finishing process. When you go with machines, it will be like a simple and scalable. Uh, Also, it's a neat and clean environment. So this is a big transformation required here for the trimming. Also, in industry 4.0, we need to monitor each and everything to maintain the output and maintain the uh, productivity. So this trimming process is very essential here. I'm going to show that, I'm going to share some advantages of trimming process. This first one is the cost-effective machine and process. This is a capital equipment, and you can get payback period very short notice, and process also it's very effective, easy process. And when I use the trimming machines, the noise pollution is lesser compared to that usual grinding process. And operator friendly work environment we can able to adopt here. This is the benchmark for pattern size correction. That means when you make a trimming, it will show how your product is deviated from the given dimensions and tolerance designed while designing. So this is the what we feel that this is a very important adapting the trimming process. All of your that's this trimming casting finishing industry. And the other thing is that you can get uniform productivity, easy to increase the production. That means, suppose if you are making 1 lakh component, if you wanted to increase by another 1 lakh component by a couple of months, you can increase by simply adding the machine. If you have a inventory in that raw casting. And other thing is clean, you can maintain the clean work area here. Hello, am I audible, sir?
Yes, sir.
Yeah. Yes, sir. Yes. Yeah. That other thing is that you required while trimming, you required minimum task force or less labor dependency here. So if you have a minimum labor force, and if you have trained, if you train the forces, you can utilize throughout the day in this process. Each and every casting we will get we will go compliance with the go and no go cages. So it's 100% foolproof here, and environment friendly. Here this environment friendly, you cannot see that flying ash or some dusty these things all there. And since it is having the progressive cutting, the metal, the parent metal will not fetch from during the finishing process. This is a very important thing. While doing the bench grinding or the other things, some mark will be there in the casting outside. But here it will get a uniform, progressively uniform cutting edges. And because of that cutting edges, you can get a consistent in dimension, size, and repeatability you can get. So even if you are getting thousands of component on 1 lakh pieces, you will get a repeat same dimensional variation. I mean, there will not be a very much variation in this dimension. So this is very useful. And this is used for improve the productivity and process efficiency. This is the indicator for dimensional quality. It's not only the dimensional size, the quality means this is a finish and appearance wise, everything is will be included here. And other thing is this trimming process will show you the process issue over the time. What I mean to say here, suppose you are adapting a trimming machines for your particular product. After 1 month, 2 months, if any deviations found in the dimensionals, the machine will indicate the load variation and pressure variations, so that you can identify easily that there will be a material addition, some dimensional deviation from your pattern. So you can correct immediately. So this is a very important here using the trimming machine. And the other thing is that you don't require the, I cannot say that don't require, there's a minimum secondary operation. Some of the area you cannot trim, so that area only you require the secondary operation. This is doesn't having the vertical cutting edge. Other thing is that reduction in operation cost, that recurring cost is very less compared to that usual traditional method. Improved and uniform surface finish. This is a very important factor. Uniform surface finish you will get, unless like scratch marks and patches, you will not find anything here. You will not find anything here while using the trimming process. And higher machine utilization here, so downtime is very less. That means you can use 24 20 throughout the day and all over the, I mean, all the day of the week. So you don't need any, since it is a machine, you don't need any special attention. It's a minimum maintenance is required. Since it's a proven and the technology, it's minimum maintenance is required. Since it is the automated trimming, this is the faster and lesser cycle time compared to other things. Suppose a man making, two mans making the grinding, finishing the product of 1 lakh component. This machine will make within a shift instead of making 3 shifts. So this is the major in point. Here, you can use the indicator of inventory trend ratio. That means how you are producing, how you are billing. This ratio can be monitored by while using the trimming process instead of traditional finishing process. The main thing is that trimming reduces the risk of injuries to the operator or labor. So this machine is very much capable of avoiding that injury because that we have some laser system, all those things. So it will stop automatically. So this is a very important factor. And obviously everyone will expect that faster return on investment. Of course, our machines will give, I mean, this process within 2 years, approximately, I'm saying. 2 years, we'll get it, the machine. Yes, sir. Anything wanted to say, sir? Hello? Hello? Shall I proceed for next slide, sir?
Yeah. You can continue, sir.
Yes, sir. Please.
Yes, sir. Any points on this advantages of trimming process, all those things?
No, sir.
Okay. Yeah, I'm going to show you that our trimming machines for using this recent trimming process. We have built so many machines. I'm just putting some slides to understand that how big this machine is and how to make some the basic cycles, all those things. I'm just putting that slides. This is. Are you able to visible this? This is visible to you, sir.
Satish Kumar, Shiva Kumar, Shardan Kumar.
Yes, sir.
Yes,
It's very much useful.
Yes. This is 120 ton, 125 ton hydraulic press. There is a man behind the machine. To understand that, I'm just keeping this man. So this is almost double the size of height of the man. This is 125 ton. This will cover almost all the casting from around 12 inch to 16 inches casting as and today we are manufacturing. This is a new development from our side to optimize the piping clamp industry. This is a 125 ton press industry. And if you see, this is the one SPM. In trimming, the general thinking is that we cannot trim more than the vertical edges. This is the so far scenario, and so far machineries. So far we built the machineries. Now we tried out the machine. This machine, you can do the trimming with the taper faces also. That means if any inclination in the inclination trimming also we can do with this SPM machines. So this is our new product development machine, sir. And this is the 100-ton machineries. This is 100-ton machineries for various applications tools. This is the 63-ton machineries for various product, especially for the railway insert product. This is the 30 to 40-ton for rack ram and other small product. This is the pillar type press. This is also can be used for that other application and railway product. this is the typical trimming tools look like. If you see this cursor, this is a tool set. This is a holding device. This is a housing. What we call it as housing. This is a trimming tool set. It look like while mounting on the machine. This is the blade. We call it as a blade. Somebody we call it as a die. This is a die for housing and the carrier for this car. If you see, no. Yeah, this area there is a disc brake arrangement. No, this for disc brake arrangement. We are making trimming machines. This is the trimming. This is the housing. We call it as that piston housing. This is a housing blades. This is the disc brake carrier blades arrangement. This is a carrier before and after trimming. This area, it's trimmed area. You can see here. This is some Rakram product, various type of Rakram product. You can use for various machineries. It's like 30 to 63 ton machineries. This is one of the die set for that housing. This is also trimming housing. This is also the trimming housing, sir. Well, I am charged. Yes, sir. This is the trimming machine, RT6901 trimming tool machineries. You can use for the railway insert. This is a railway insert, sir. This is the gauges system to find out that any deviation after trimming. This is a checking system. This is a video. I will show you in separate tab how it is trimming happening. Yes, sir. So some list of customers are here. So far we supply to that customer. Yes, sir. And I'm going to show you some videos to you. Yeah, the videos are playing, sir. Are you able to see the video, sir?
No, sir.
Is it okay now? Hello? Sir, am I audible?
Okay, sir.
Yeah. Yeah, this is the this is a DI frame trimming machine. The DI frame in the sense this is a piping clamp for this water system and water system in the cold region. Thus, we built the complete turnkey solution for this, making these things. One is that ID trimming. This is the OD trimming machineries. If you see, I am just stopping here. this is ID trimming machine done by other machine. This profile is done by separate machine. This is a OD trimming machine. This inclined plane 15 degree also trimmed by other machineries. We build a separate SPM. Hereafter that video will come. Yeah, you please see that.
Low cost emissions. Low cost.
Yes, sir. It's visible now. Yeah, we are introducing the coolant system also for these machineries. This is improving the tool life and reduces the recurring cost of tools. I mean that resharpening duration, so that the cost of life of tool increases, though the cost is reduced. Yeah, this is the SPM machines. What I told you, know, this angle cutting machines. Sir, are you able to see this? Hello.
Yes, yes.
Yes, sir. Sir, this is a angle cutting machine. This we developed as a low cost solution for this application. This is the recent development in the trimming industry. So this is the benchmark machineries. You can do any degree. Any angle within 360 any degree in the within the 360 and up to 45 degree tilting also you can able to do. I'm showing you the other video.
Hello. And the presentation of our corporate. Ready.
Yes, sir. Just a minute.
Questions can be done. What was the number that? Right. What you said. The command question that came. It's a. Need for sir. The SPM of Jakarta. And sleep in the hotel. I'm a bit government.
Hello.
Yes, sir.
Sir, are you able to see the video of?
No, sir. No.
What's happening? Just a minute, sir. Yeah, now it's able to. Is it visible now? Hello? Hello?
Yes, it's visible.
Yes, visible.
Yes, sir. This is the railway insert trimming video. If you see this component is coming behind that after trimming this will take only 6 seconds maximum, 5 to 6 seconds. This is that our we optimize that cycle time. It's nowadays a monthly volume. It's more than 2 million, I think so. So we supplied last year itself around 15 machineries to various customers. This is the one more machineries. This entirely different concept. This is the component is pressed and pushed downwards. This you have to put the component inside the machine and you have to take it away. So this is a two different concept. That's why that's the reason we are showing those things. Both videos are visible, sir. I've seen that. Hello. Hello.
Yes.
Yes, sir. Sir, you can ask any questions now. Yeah, that's it from the presentation. We can go for that question answer session.
Sir, you can try any cylinder head and cylinder block, sir. You are showing only that I think simple components
Okay.
like the clamp.
Sir, we are why I am showing this small component to this bigger 12-inch component. We can able to make a trimming process. We can adapt that any kind of trimming. The thing is, if you show me that component or if you send me the component drawing, we can able to. I mean, we will study and update you, and we can provide the best possible solution to you.
Sir, trimming means you can remove the extra projection only. But
Yes.
at the time of trimming, we cannot. Your machine will perform that matching between mold profile and core profile.
Yes, sir. In the final dimensional, you arrived with a drawing, no, sir? That whatever the things excess the drawing, we can able to cut the material.
But what form of cutting you can use with grinding wheel or
No,
like wedge?
It's not like that. It's like it will work like a knife. This is it. You can able to. This is the basically in engineering term. It's a shearing process.
Shearing is the removal of excess material like extra projection.
Yes.
Then we want you are telling that your machine also perform dimensional accuracy and then profile matching.
Yes, sir.
Then the profile matching, what way your machine will perform? You are not showing that video, just you are showing your product machines. For that only I am asking.
Sir, just a minute. I'm sharing one more thing.
Basically, a puzzle. Interesting. And there was one mention we did.
Sir, if you're able to see this photo,
Yeah.
yeah, this outside is the profile. This component is outside is a profile, and inside also it's a cone. It's not a circle. I mean, if it's a cone, inside is a lesser diameter, outside is a bigger diameter. This having some angle. It's a cone. Generally, here the trimming is a complicated because we need to cut the cone, and also if you see this area, this is a plane is tilted with respect to the basic home plane. That means horizontal plane. So why I'm shared this machine and this video, we can able to do this outer profile also. That means this is the positional accuracy is very much important while loading every job. So that kind of things we can able to do here. So to show that I'm just showing this outer profile, and the inner it's complicated from bigger diameter to lesser diameter. It's very you cannot able to do that contradictional statement. I mean contradiction. So that this is also we are trimming. We are doing inner diameter also and top side outer diameter also. So we are making the perfect cone by controlling that hydraulic element using our precise PLC control machineries. So this is also we are doing, and outside and inside also pins are there. If you see this marking area, just a minute. Why this? Is it bigger now, no, sir? Is it okay? These pins having inside cone, these pins having outside plane. To do this trimming, we need to make angular machineries. This is also we are doing. So it covers all the complicated area. To show that only I took this project this product as a example, sir.
How to select the hydraulic press capacity or tonnage?
That's why we are here, sir.
No, you
Thanks
are
for
there.
this.
I know, but
Okay.
but for say the material are different. HE iron, gray iron.
Yes,
So
yes.
depending
Actually,
upon, because it is a cost. Ultimately, the hydraulic press capacity is a cost. If you go
yes, sir.
higher side, it is too costly. If you go lower side, it doesn't work.
Yeah. This is that here our vital role is important. Our MD, Mr. Sundar, having 40 years of wide experience in this area, is basically the metal cutting machinery manufacturing guy, and also of course we are also in the team. So under his guidance, that selection, some basic calculation, it's basically calculating that tensile force against the shearing force for selecting the hydraulic presses.
So for particular matter, it remains same.
No,
For tensile is for
the
example,
cutting area. Cutting area and depth of cut also will decide that type of, I mean, the requirement of tonnage.
okay. And how to ensure that the casting doesn't get any crack during the trimming process?
We know that tensile strength and shear strength of that component. Of course, you will provide while giving that component and drawing to us for making the machineries. Based on that, we will select, sir.
No, I am asking after trimming, if casting get crack?
Yes, why is getting crack? First of all, the question is why is getting crack? You are giving
It is
that
because of-
excessive. You are giving the excessive force than that bonding force. Correct? No.
Yeah, you are the expert. You can explain me better.
Yes, yes. This is the reason behind that. Why it is getting cracked? You are giving that giving the excessive force for cutting and other finishing process. We need to optimize that in which area, with the which band it is lying, which means it's creating the perfect trimming or finishing product. We have to identify. This is some engineering calculation. It's basically some past experience. All put together will come into the play. Hello.
Yeah. And how is the die maintenance?
Sir, the die can be resharpened every some particular cycle. I can say some example with 4,000 to 10,000 component. This it will vary, depends on that job to job. After that, you have to resharpen that edges. So you can use multiple times. Multiple times means for around 3 lakh to 4 lakh component you can use. It depends on the job.
Okay. And what will be the die life, overall life, including all this sharpening?
Yes, yes. This once the die get worn out, the machine will give the alarm. You have to do the resharpening. We set such a way it will be a physical alarm. It's not any perfect for a particular cycle. We will show you that how to understood that you have to do the resharpening. So based on that, you have to resharpen the die. So you can use multiple time. For example, for 6,005, for example, 5,000 component, every 5,000 component you are resharpening the die. You just imagine. Okay, for month you are making 1 lakh component. So every per day your production rate is 3,000 numbers for the shift. So you just imagine every shift or every 2 shift you have to do the resharpen. That means it will come up to 4 lakh component. Nearly about 4 lakh component. You calculate how long you are running 1 shift or 2 shift. It's up to you.
Okay. Okay.
Anything, sir? Any questions, sir? Yeah, you please mail me, sir, if any specific question regarding this trimming process or machinery, what you wanted to make in special purpose machine. You please mail me, and you can also text me.
Hello, sir.
Yeah.
Sir, basic calculation for design of HPP. How much power HPP required based on the mm square. Based on the mm square. Have there any calculations for just?
There is no fixed calculation.
To understand.
Yeah. If you want to know anything to understand, I mean to improve the knowledge wise, you please text me. My number is 9500 61377. I'll tell you any specific calculation under.
Pardon, sir, please.
9500
95000.
Yes, sir. 61377.
You can put in the chat, sir.
Okay, sir. Now, one question. We are in the sir. We are in the business of cast iron and agent.
Yes, sir.
We have the trimming flashes, metal flashes. Is sometimes it is minimum 0.8 mm. Sometimes it may be 2 to 3 mm. because of design constraint. Because of vertical flash, we reduce up to some extent. Beyond that, difficult. Otherwise, there will be any mold crash and sand inclusion.
Sir, our machineries can be delivered. I mean, our machine can deliver plus or minus 0.5 mm flash. I mean, after trimming. So this can be maintained easily. The thing is, the flash thickness is very much important. Either vertical or horizontally spread out. This can be addressed after discussion. I mean, after seeing the casting, after study the drawing, where is the in gate, out gate position and all. So we can able to maintain plus or minus 0.5 mm.
Plus or minus 0.5 mm.
Yes.
And up to maximum, how much thickness?
No, thickness you can do that. Our recent machines we cut up to 3 mm.
3 mm.
Yes. That you require a higher size, higher capacity presses. Yes.
Yes, higher capacity press.
Yes, sir. Sir, you are from which company, sir? Mr. Deepak.
We are from sound casting. Sound casting Kolhapur.
Oh, Kolhapur, sound casting. Okay, sir. Okay.
Sir, also we have some any mold crack or extra metal with the casting. If sudden there is a force to the machine, is there any detection means present have?
No, actually, that is the detection is separate. We are talking about the metal cutting. So the detection that is different.
Yes, sir. What happened, sir? We are our process is of sand casting. Okay. We have high pressure line. Then also sometimes mold get break and some extra metal comes around the casting component.
Okay.
Like if I use this component for trimming, then the cutting force may increase, or sometimes they instead of tool get break or die get damage. Is there have any pre-sign from machine?
No, yeah. Actually, this sir, we can able to do. We can able to detect that what is the holding pressure and holding. I mean, cutting pressure. In other hand, I will show you that you can use the load cell to detect the load. But that it's too costlier. It should be affordable, no? That you have to think either it is required or not. That you have to think.
Sir, instead of getting the die damage, that kind of a technology inbuilt is better, na?
Yes, you share your component, and every component is considered as a new project. So if you want, I will inbuild and give it to you. You can use happily, no, sir.
Okay. Sir, one more question, last question. Any user near to Kolhapur or Maharashtra, these are using your machine?
Silvassa.
Silvassa, there is a user, and Pune. Pune. In Chorus, they are using our machines. You can visit. Silvassa also near Mumbai.
Where, sir?
Silvassa, Siddhi is used.
Yeah, Siddhi. Yes, sir.
Sir, pardon, sir.
No, Silvassa, Siddhi Bharas also using in near Mumbai.
Silvassa.
And Pune also Chorus they are using our machineries. You can visit. Or if required, if required, you just share your component, all those things to me, and we'll discuss separately after this session.
Okay. Thank you, sir, very much. Thank you very much.
Please wait. Our MD wanted to share some words. He is here. Please wait, sir.
Okay.
Good afternoon, everyone.
Good afternoon.
Our sincere thanks to Institute of India Foundrymen, Mr. Senthil Kumar, Chairman, Rajamohan, Mr. Mathivanan, for organizing extraordinary meeting today. I would like to share some of my views. I am delighted to share a milestone that has not only challenged us technically, but also elevated our confidence as a team. I had the opportunity to visit a foundry in Sildasa that is producing an impressive 6 lakhs insert per month for Indian Railway project. While their production scale was commendable, they faced a persistent challenge in finishing and fettering operation. That was actually a bottleneck for them. That was affecting their output. Our team developed a trimming press and tool with a cycle time of just 6 seconds, fully compliant with go-no-go gauges. It was really a leap in precision. It was really a leap in precision engineering and process efficiency. We went on to supply over 25 presses and trimming tools to cities across India: Raipur, Hyderabad, Calcutta, Bokaro, Durgapur, Bilaspur, each tailored to meet the specific needs of their operation. This project has been a turning point for us. It has boosted our confidence in designing high performance presses and tools. I would like to extend my heartfelt thanks to Breaks India Foundry Division Solinger for entrusting us with this trimming opportunity. Our sincere thanks to ED, Mr. Narasimhan, now ED, Mr. Surya Prakash, and their support and belief in our capabilities played a crucial role in making this initiative success. Now we have reached a level where we can design a trimming press and special purpose machine for finishing. We are looking forward to your inquiries. Thank you very much for the opportunity. We look forward to your inquiries again. Thank you.
Yeah, thank you, sir. Thank you,
Thank
Madhi.
you,
And
thank you.
yeah,
Thank you
thank you,
for your
Sundar.
wonderful opportunity. Thank you for all the participants and organizers. Thank you all.
Yeah. It's my privilege to give the word of thanks, and I, on behalf of
Sure.
Indian Institute of Foundry, and first and foremost, I would like my heartfelt gratitude for the distinguished speaker, Madhi, and sincere thanks to all the respected people who have joined today. And finally, big thanks to the technical support team for ensuring a smooth online experience through. Yeah, once again, we thank each and every participants for the meeting today. Thank you very much. Have a great day.
Thank you all.